Hello, I'm Sonic. We will learn about asymptote of a curve. An asymptote of a curve is a line such that the distance between the curve and the line approaches 0 as one or both of the x or y coordinates tends to infinity. Also, asymptote of a curve is a line which is tangent to the curve at a point at infinity. The word asymptote is derived from the Greek asymptotos, which means not falling together. There are three kinds of asymptotes, namely horizontal, vertical, and oblique asymptotes. For curves given by the graph of a function y equals f of x, horizontal asymptotes are horizontal lines that the graph of the function approaches as x tends to positive infinity or negative infinity. Vertical asymptotes are vertical lines near which the function grows without bound. Oblique asymptotes occur when the degree of the denominator of a rational function is 1 less than the degree of the numerator. First example, f of x equals 2x squared plus x plus 3, divided by x plus 4. Find vertical and oblique asymptotes of a curve. We can take this denominator, which must not be equal to 0. Take x plus 4 equals 0. Then we get x equals minus 4. We know minus 4 is excluded in the domain. Its vertical asymptote can be obtained as x equals minus 4. To find oblique asymptote, we may have to divide 2x squared plus x plus 3 by x plus 4. This becomes y equals 2x plus 7. We can now plot them in the graph, one containing vertical asymptote and one oblique asymptote. You can notice the tangential curves touch on one of the asymptotes. Another example, one for the horizontal asymptote. f of x equals 2x squared minus 3, divided by 3x squared. What is the horizontal asymptote? You will need to take the coefficients of x squared, in which y becomes 2 by 3, that is 0.66. We can now depict this in the graph that you can find out the asymptote. So, you now know how to find asymptotes of a curve. Like, comment, and subscribe now.